Hey guys, Mike here from Applied Engineering and Design. And I got another tutorial for you guys today on some simple four-axis machining using RhinoCAM. The ability that RhinoCAM has to work in four axes is actually quite cool. I designed up this part here, just basically made it in Rhino here, just playing around. So thought it would be pretty cool to see if we could machine this. Basically set it up to be able to be machined on a Haas four axis, which is what I have. So let's get started here. Basically, what we want to do is we can take a look at this part and kind of think what sort of stock and everything we're going to want to use for it. So I'm thinking we're going to use just a piece of cylinder stock. What we'll do is let's get the stock right on there so we kind of know what we're looking at here. So we're going to right-click stock. We're going to hit cylinder stock. And our axis is already set to X here, which is what we're going to do. So what we're going to do is set our radius to 1.5, which is just bigger than that, about 3-inch total diameter, and about 6 inches length, which will give us, I believe the part when I made it was about 4 inches total, so it'll give us about an inch on each side. If we go ahead and hit OK, and we'll go to Align Stock, Center Z Alignment, and center XY. And if you take a look on the side here, you can see it's pretty much centered right inside that cylinder. Let's hit OK. And we'll set our world coordinate system. We're going to set to stock box. We're going to do mid-Z. And we're going to do east because on my machine, my fourth axis is on the right side. It moves in the negative X direction. And right there is where we'll touch off on the part. So hit OK. And we'll turn the stock on so we kind of see what we're looking at here while we're working, which is cool. So let's set up the machine now. The first thing we're going to do is make sure our machine is set into fourth axis mode. So we're going to right-click our machine. Double-click our machine. And we're going to look, and our number of axes is set to 3. So let's go ahead and set to 4. And our configuration is table, which is, since we're not using a head. Come down to our fourth axis parameters, and our rotary axis on mine is actually going to be -X, and you can see the little arrow switches direction there. And we're going to do no limit and hit OK. So that's pretty much good to go. My post is already set up for Haas with cut comp, which if you've been following any of my other tutorials, especially the last one, which was on setting up your post processor, should have a similar post processor setup, but you can use whatever post processor you want as long as it supports the 4-axis rotation. Now that we're pretty much set up, we can get going. And the first thing we're going to do on this is I want to have some tabs so that this part can still be held while we're machining. This full stock section is going to be held. So first thing we're going to do is I'm going to go ahead and draw circles and draw like a cylinder straight through the part. And here's it from the top, so we're going to go ahead and look at it from the right. What I'm going to do is go ahead and select circle and hit 0 for my center, and I'm going to set it up so that we've got a 3/4 inch shaft running through. And if we look at what it's going to be is going to take that, turn off our stock while we're working, and I'm going to drag it across. So actually, take that circle, and I'm going to hit Alt and click on my gumball. And because we know we want it to be at the complete other end, and our stock is 6 inches, I'm going to hit -6. And so now I have 2 right there. So what I'll do is I'm just going to start dragging across, hit Control, drag it right on top of the other one. Now we got the cylinder. I'm going to go ahead and delete those curves out. And I'm going to cap this by typing cap. That's going to create a solid poly surface. And what I'll do is I'll move it into my surfaces layer, going change object layer. So now what we're going to do is we're just going to combine these so that it's one solid part. We're going to start typing Boolean union and select the 2 surfaces, right click, and we've got one solid mesh now. So that's going to help when we start doing our 4-axis and our 3-axis roughing. That's basically how it's going to be held. So jump into the top here, and what we're going to do is we're going to draw a rectangle that's going to basically contain our horizontal roughing. I'm going to turn on grid snap, and we're going to go about halfway up into here in this box, and we'll come right down into this box down here, centered. And if we look, it's pretty much exactly where we want, and that's what we're going to contain our horizontal roughing to. So the first thing we want to do is take care of these holes. Now, the way I drew this part, it was easy to draw, easy to model, but in looks, you can't just kind of click your circles and start drilling. So I'm going to show you a little trick, what we're going to do on this one, and we're going to start with this top one here. We're going to type DUP, and up should pop dupe edge. We're going to hit OK. We're going to select this edge here and right-click. Let's head into top mode, and we're looking right down on it, because if you look in perspective, it's not completely flat, so we want to flatten it out. We're going to go to top, and we're going to start typing project, and up should pop project to C-plane, and if it doesn't, just choose project to C-plane. Going to hit enter, and delete input objects, we're going to click yes. And what that is going to do is if we pop into perspective and turn off our surface, you can see that it just created a flat circle right there, which is perfect. We're going to do that for the other one as well. So turn our surface back on, and we're going to come over here to this one, dupe edge, select that, and we're going to come into our front, and same thing, project to C-plane, delete input objects, yes, and turn off the surface. We've got two circles right there. That's exactly what we want. So because we know what our stock is, I'm going to go ahead and move this one out 1.5, move this one up 1.5. And then we're going to create duplicates by holding Alt and clicking and doing -3. And the same for here, Alt, click, -3. Now we've got these 4 holes that correspond to exactly the holes we want to drill. Awesome. So now we got to do the other ones here. So what we're going to do is turn off the surface. We can actually get rid of that guy there. And we're going to window select those. So we've got them. And what we're going to do is turn our surface back on. We're going to go into top. And we're going to hold Alt and drag it right across until we lock right into the center of that. Oh, it didn't copy. Oh, nope, did. I'm sorry. It did copy. So, all right. So we got duplicate. We got 4 holes on the front and 4 holes in the back here. And all we need to do now is rotate 45 degrees because these holes were done 45 degrees like that. So we're going to go ahead and click our X, 45, boom, good to go. So first thing we're going to do is we're going to drill our holes. That's the easiest thing. We're going to go ahead and create that. Our setup is going to remain this 0 setup, just the standard 4th axis setup. We're going to go into holes, hit 4-axis drill, select our holes, and we're just going to window select each group of 4. Right click, go 8 holes we're going to drill. Go over to tool. I've already got the tools loaded in, but this is where you want to create your tools and set your feeds and speeds. I did that before starting the tutorial just to make it easy. We've done plenty of tool creation as well. So we're going to choose our 1/2-inch drill, feeds and speeds, click load from tool, make sure everything's good. Clearance. Now you can see our clearance plane is a cylinder in the 4th axis. So I can go ahead and turn the stock on, and you can see that it's about 1/4 inch around the whole stock. And that's exactly what we want. We're going to leave that alone. We're going to leave cut transfer method to clearance geometry. Cut parameters. So we know we have a 3-inch cylinder, and we're going to drill from both sides to create a nice hole that goes straight through. So we're going to choose 1.625, add tooltip. And that's quite a long drill. I don't have through spindle coolant. If I did, we would do it in a one pass, but we're going to do deep drill and we're going to peck it. And because it's a 1/2 inch drill bit, we're going to do about 250 thou or 1/4 inch per step. And let's hit generate. If we turn our toolpaths on, we can take a look. And basically it works its way all the way around, does all 8 holes. Let's take a look at the simulation. And it comes through, and you can see it goes right through all 8 holes. And that's exactly how we want it to start. Awesome. Let's move on to the next part. And you can even see in the stock the see-through is very, very cool. Okay, now that we've got our holes drilled and programmed, and you can see it on our simulation, we're going to go back and start working on the horizontal roughing and the parallel finishing. The one thing to note here is that we don't need the roughing or the finishing to go into these holes because we drilled them. And as far as I know, there's no way to prevent parallel finishing from actually not going down into there. And we'll have to talk to the Mexsoft guys to see if that's something they can add or if there's a way to do it that I'm not doing. But for now, what we're going to do is we're just going to delete the holes. So we're going to use the command delete hole. And we're going to go through and click the holes. And basically that removed all except for 2. So what we're going to do is we still got to get rid of those. So we're going to go ahead and switch to ghosted so I can kind of see what's going on. I'm going to explode the surface. I'm going to delete these extra surfaces that are in here that we don't need. And by having it in ghost mode, I can kind of see what I need to do, what I need to get rid of. Okay, cool. What we're going to do is we're going to patch up those 2 using the patch command. We're going to pick those edges. Okay, and preview, and you can see it sticks a nice little patch in there. Okay, and we're going to do the same for this hole over here. Preview. All right, cool. So now what we can do is take this whole thing and join, and it creates one closed poly surface, which is okay, even though it's got that weird mesh there. Everything is good to go for us to start writing the program. So the first thing we're going to do is we'll turn our curves layer back on. We have our square that we're going to work with here. The first thing we're going to do is we're going to go ahead and select 3-axis advanced and do horizontal roughing. And the only drive region we want to select is that square we created right in the beginning. So for tool, we're going to use a 1/4 inch end mill. Feeds and speeds load from tool. Our clearance plane is now a 2-axis clearance plane. And our cut parameters, this is our into and out stock, and that's basically how far out or into the part geometry you can go. And we're going to leave 25 thousandths of stock for this. And our step over, we're going to leave all this default for right now. Our cut levels, our tool diameter, we're going to lower this down to 25%. And because this is going to keep us within here for X and Y, we only want to go down halfway, or maybe a little over half, because then we're going to flip it around. So let's set our cut level bottom. We're actually going to set to minus 0.05, so minus 50 thousandths. And we're going to engage and retract via path, and leave everything. Let's turn on some of our arc fitting and smooth cut connectors, and we're going to hit generate. And you can see it created a nice little path. If we simulate it, turn off our tool, you can see what it does right there. Kind of creates a nice little rough path of it. And this red mark up here is actually the tool holder colliding with that. So we can come in here and let's say, all right, we need to use a longer tool to prevent that. We're going to make sure we need a little bit longer tool. Save edits to tool, and we might as well go ahead and do that with our ball mill, because that'll end up having the same problem. Hit OK. And if we regenerate, and resimulate it, you can see that it's now no longer hitting there. Great. All right, so the next thing I'm going to do is we're going to rotate 180 degrees. Let's go back to program, and we're going to go to our setup and hit rotate table setup. Our table rotation angle is going to be 180 degrees to go completely around, and I'll leave it to counterclockwise. We're going to hit OK. And you can see right here that our arrow, our Z, is now pointing down. So we're literally going to take this and Control-C, Control-V for copy and paste. And you can do it by right-clicking as well. What we're going to do now is go ahead and just hit regenerate. And if we turn on our toolpath, we can see almost nearly the exact same toolpath from the opposite side is coming in. If we simulate that as well, you can see we've got a real nice roughed out toolpath now of the part. We're almost done. Now what we're going to do is we're going to rotate back around, back to program, setup, rotate table, set this to 0. Hit OK, that puts us back where we were. And we're going to go ahead and go into 4-axis, and we're going to choose parallel finishing. We're going to hit remove all, so we're going to use the entire part to calculate. Our tool is going to be a 1/4-inch ball mill. Feeds and speeds, load from tool. Clearance, we're going to leave alone. It's that automatic clearance that looks pretty good. Our cut parameters now. All right, this is where it gets important. So our in tool and out tool is, like I said, the tool path, that how far in and outside of the part geometry it can go. And we're going to do 1/1000th for both in and out, and our stock is going to be 0. So we want to finish this right to the part. So now we need to come down, and our cut pattern is going to be a long axis. This means we're going to move back and forth and zigzag. And we're going to set this from high to low. So if we take a look, now what we want to do is we want to make sure that that cylinder we created for it to stay held in the 4th axis remains there. So we're going to set our low value. If we look down from the top, we want our low value to basically be the same low value of that box we created. So we know we can actually take a quick look in Rhino. We see in the bottom left-hand corner it's 5.5. We're going to set our low value to minus 5.5. And our high value we know is minus 0.5. A 1/2 inch in because we used grid snap for it. And our start angle and end angle are going to be 0 and 360 because we want it to go all the way around. For our step over control, we're going to set this to 5% step over of the tool value because we want a real nice fine finish. And we're going to leave everything else the same and just go ahead and hit generate. And we can take a look at our toolpath, and you can see it's got a real nice smooth toolpath around the whole part. Let's simulate it. And even on this pretty high horsepower CAD machine, it can take a while even to simulate it. You can see that it's over 55,000 lines of code. And I have it on pretty much as fast as it'll go. Once the simulation is done, we can turn off our toolpath visibility and take a look at how nice it came out. You know, maybe a little deburring and some finishing, and this will come out pretty good. That's pretty much it for your basic 4-axis. We did a little bit of 4-axis drilling, some 4-axis roughing. Technically, we did it as horizontal roughing from 2 sides. So that was 3-axis toolpaths using the rotate table setup. Then we did some 4-axis parallel finishing that did it across the whole part. If you guys have any questions, you can go ahead and contact me at info@appliedengdesign.com. I'd be glad to help out with as much as I can. And we will have a website up soon, so check that out. We'll have cool blog posts And subscribe to our YouTube video if you want any more. And if you have any other ideas for videos, contact us or contact the guys over at MechSoft, and they'll pass the word on to me to do some of these videos. Once again, I appreciate you taking the time out to listen to this, and see you on the next video.